Okay, so this lesson is about the phases of the moon, how the moon seems to change shape over the course of a month, and the progress and the cause of that, and understanding it. Now, this used to be a really kind of an important thing for human societies in that it didn't always have calendars, didn't always be able to, know what the days of the year were. And so a lot of the calendars were set on the cycle of the seasons, like you had the spring equinox or the summer solstice, something like that, but also phases of the moon because you could have different villages around there and they go, okay, it's full moon. Everybody knows it's full moon. So the festival will be held like during the first full moon after the spring equinox or something like that. By the way, Easter is still kind of geared by the full moon, because it comes from a culture with a lunar calendar. The whole idea of the 7 day week, a lot of that is because of the quarter phases take about 7 days, so human beings and people, we get our sense of time from the sky. Now, living in a culture that lives indoors most of the time, we get it from numbers and from a calendar, from a clock, something like that. But still, being in touch with the cycle of the moon is a worthwhile thing, and knowing how it works from a scientific perspective, where the earth goes around the sun and the moon goes around the earth, and understanding how that works. Okay, so it helps us be aware of the universe that we're living in, the world, the cosmos we're living in. And so phases of the moon is the name of the lesson. Now the moon, here's a really good photograph. You have to use like a telescope to see it that clearly, as the dark blotches in the light areas and things of that sort. Well, what of these are? It turns out these are crater marks. The craters, when the moon was first forming, come smashing in and bust through the crust. And with the Apollo moonlight landings, they realized these darker areas are called mare, which means sea, like the Sea of Tranquility. Mare Tranquillitatis is where Apollo 11 first landed. And anyway, they are actually younger than the oldest part, which is the white part, because when the crust first started forming, then a meteor would come busting through, and you could see these big, giant craters where the lava would come gurgling up. Now, the moon now is frozen solid. It's solid rock. There is no liquid, molten interior like there is for the Earth. And so, anyway, something else that's amazing about it is this same face always faces the Earth, right? There is a backside to the moon, but nobody ever saw it until Apollo 8, when the Americans, Buzz Aldrin and stuff, got into uh, the Apollo capsule and went around it. Oh, actually, I said Buzz Aldrin. He was one of the guys that first landed on the moon along with Neil Armstrong. It was Jim Lovell was one of the guys, and Bill Anders. So anyway, it always faces the same side, always faces us. I'll get to that in a second. Now, this picture here was taken by a probe that was sent away from Earth orbit. And so as it was leaving, going off to Mars, it turned back and took a photograph. So this is the Earth and the moon. Now, the distance here is a little off because they aren't exactly 90 degrees angle, but the size is about right. You see how they're both lit. Barely any crescent shape at all. That's because they're lit coming from this side over here. Okay, now the phases of the moon. This photograph is pretty interesting composite where you can see the crescent and the crescent shape, and it gets bigger, bigger, bigger as it goes on. Then you get to the first quarter. It's a quarter of the way through its cycle. Now, this is a little deceptive because they call it a quarter moon, but it's really half of it, of our surface that we can see. Half of it is lit up. So when it's split 50-50, they call it a quarter. And then you think it's bigger than this. This is called the gibbous moon. You should know that from a prior lesson. Till it gets to the full moon, and then it starts having a crescent-shaped shadow form on this side here. So this is still gibbous because it's more than half of it is lit up, but now it's waning gibbous because it's getting smaller, 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 and there's the cycle of the seasons. Now, have your paper ready. Anything in white, you got to write it down, okay? And so here we go. The moon shines from reflected sunlight. Write that down. So the first thing to know is the moon doesn't actually glow of its own shine. It's reflected sunlight. So what we have, please write that down. But if you've ever seen one of these really slender crescent moons, which I really love them, I think of something like a smiley face moon sometimes. You can kind of see the dark side. Now, the reason you can see that is because that is reflected light reflecting off the earth shining on the moon. That's earth shine. And that's why this seems more seems better lit than if you don't see the thin little sliver. That's because when you see the sliver of the moon, if you were on the moon, you'd be seeing most of the earth illuminated because the sunlight coming from that direction. Okay, next one here. The moon rotates at exactly the same rate as it orbits the earth, so the same side always faces us. That's kind of another very interesting thing. You'll always see the same face, and nobody ever saw the back until Apollo 8, like I mentioned. And if you need to pause the video to write down what's in white, go ahead and do that. But, okay, so here's a little model of the globe of the moon. And if I'm looking and I see this side here, and it's going around me, what has to happen is the moon has to be rotating as it's orbiting me, as it revolves. Rotation is to spin on your axis. A revolution is to go around something. So think about it. If you're on the earth and you're looking and the same side always faces the earth, that means as it goes around in its orbit, it has to rotate one time as it revolves one time. Does that make sense? Can you see? As I'm going around like this, that means that the moon has to be rotating as it goes around. And so that it's locked in place like that, which is the reason that happened is because the moon actually formed in Earth orbit. And it's a little bit off center in its mass, little known fact. Okay, so it's sort of locked in that orbit. Something else that's kind of intriguing is the moon is actually moving a little bit away from the Earth, about 2 inches every year. And in a million years, it's going to be further away than it is now. In the dinosaurs, age of dinosaurs, they would have seen the moon bigger in the sky.